So, which gives me a second to introduce our next speaker of today. Feline, working for the university in Delft, TU Delft. We actually have two speakers today from the TU. That's also our Derek is from there. You're going to talk about Excel. You were here a month ago talking for the PyLadies. Is it the same talk you're going to do, or is it slightly?
Half is the same, so I apologize to all the people who saw my talk a month ago. In the first half, you can sleep. It's the same.
Not so many ladies here, so I think it's fine. Are you going to tell the story about the gas turbine?
No, it's not in
okay,
this
so
one.
I can do that as an introduction.
Yeah, go ahead.
Like the
You
first
can
time
have
I saw a presentation from Feline, it was also about Excel and the way it's like everywhere. And one story was that this company invested $2 million, I think, dollars or euros in a gas turbine. So they got the thing installed, and then they wanted to switch it on. And then it turned out that it didn't come with any software to automate the gas turbine, which, well, is a bit of a pity. So they said, well, can you write us a piece of software to automate this? And they said, well, yeah, we can do that. It's also 2 million. Well, we don't have any budget left for that. So what do you do then? You ask someone to automate it, and they pick Excel. And so they have this $2 million gas turbine, and they automate the thing with Excel. And if that was not big enough of a problem, the guy who automated the thing in Excel turned out to be
64 and a half.
and going for retirement in like half a year. So, which brings us to like Excel and how it solves or creates like new first world problems. But you're going to tell us all about that.
Yeah.
So please give a round of applause for Feline.
So yeah, hi, my name is Feline. I'm also Feline on Twitter, so if you're tweeting, then you can give me a mention so I can see what you like or dislike about my talk. I can improve it the next time, like if I'm here again next month. So maybe you're wondering, why are we talking about spreadsheets? Why? I'm going to assume you're all developers. Are you all developers? Who's not a developer? Okay, so half is developers. So why should we care about spreadsheets if we're developers? Often spreadsheets are mislabeled. Many people think that spreadsheets are data, but I think they're really wrong. Spreadsheets aren't data, spreadsheets are code. This is like the gospel of my life. I go all around the world to tell people, the happy world, that spreadsheets are actually code. So if you remember like only one thing from my talk, this is the most important thing. Spreadsheets are code. So maybe you don't believe me. That's okay. I understand that you might be a little bit skeptic about that. So I have 3 reasons why you should actually believe me that spreadsheets are code. First of all, spreadsheets are used for very problem. Here you have an investment calculation, you put some data in, and you get some outputs. You could make this in any programming language. You could make it maybe with Objective-C, or in an iPad app, or on Java, or in Node.js. Any programming language is okay, and so is Excel. You could also, of course, wonder, why do people do this in a spreadsheet? As with the gas turbine, why do people not use a normal programming language? I have asked this, of course. In my years as a spreadsheet researcher, I've asked people, why in a spreadsheet? And why is that? Because we as developers, we're super bad at making software. Those guys, they have tried to buy software, to have software developed in-house. And they go to their favorite IT supplier and they say, hey, we want this simple calculation. Can you build that into an application? And the answer is often, sure, that will take 1 million euros and 6 months. And then even if they say yes, probably it's 2 million euros and 9 months, and it will have half the features that they want. So often, because we are just lacking in speed and cheap solutions, people think that they are better programmers than we are, and that's why you end up with a gas turbine ran on a VBA spreadsheet. So I go to great lengths to convince people to make my point. To such great lengths, in fact, that I have implemented a Turing machine in spreadsheet formulas only to show that spreadsheet formulas are really as powerful as any programming language mathematical proof right here. So what you see here, one row is one iteration of the Turing tape, and with additional formatting I have the head nicely moving over shape. So in addition to it being proof that spreadsheet formulas are Turing complete, I think it's also a pretty nice visualization of what a Turing machine is. So they're Turing complete. Many people enjoy this. It's not just that I really like the Turing machine. It sort of went viral over the internet. If you Google for Excel Turing machine, you find many references to it. It was so popular for a while because it was in Hacker News and it brought my website down for a day. Super awesome. So the third reason that spreadsheets are really like source code is they suffer from typical software problems, like a lack of documentation. That sounds familiar. 12 different people involved in a spreadsheet often during a very long time. Spreadsheets are live programming. Does anyone recognize this visual? Anyone know who made this? Yes? A hipster. He's called Brad Victor. He's indeed quite a hipster. So he says, what we should really have in programming is live programming, where you have your programming, your source code on one hand side, and immediately next to it, like without a compilation cycle, you need to have the results of your programming. And this is like 2 years ago that he came up with this. That's awesome, Brad Victor. We had this shit in VisiCalc since, I don't know, the 60s. Spreadsheets are live programming, no compilation needed. You input your formula and you get your result right away. Who likes functional programming? That's sort of back from the dead. All of a sudden, functional programming is super hip. You know what's also functional programming? Excel. A formula can only refer to other cells and calculate the input based on the cells. No side effects are possible. No formula can mutate any other formulas in the spreadsheet. It can only take values and calculate a result. Pure functional programming. How cool is that? The third reason you need to learn spreadsheet is everyone can do that. Your next door neighbor, your accountant, everyone in the world knows spreadsheets but us for some strange reason. It's really the Lanka of computing. If you ask someone to calculate something and he doesn't have a CS degree, what will they grab? A spreadsheet, if it's not a calculator or a piece of paper. So I think it's very important for us to understand how other people program, in a sense. So you're here anyway, so let me show you a little bit of programming in a spreadsheet. I'm going to implement selection sort, a sorting algorithm using spreadsheets so you can see how awesome Excel can be. So I have a number of numbers here, just a line of numbers that I want to sort. How selection sort works. Okay, that warrants some explanation. The idea of selection sort is that you sort a list of numbers by just selecting the lowest number and putting the lowest number at the first position, and then you repeat the same trick again by checking the next, taking the next minimum and placing it on the top of the row. So we add an index, and of course then for selection sort, the first thing that we need is a minimum. Well, Excel has a function for that. We just take the minimum of this row, and then we get the result. By the way, you can also, many people do not know this, and this will come back all the way at the end of my algorithm, you can also say the minimum of an entire row. This syntax is more well known, I think, for columns, where you have A, column B, but you can also do it for rows. So 3, column 3 is the minimum of the entire row. What we want to do now is not only find the minimum, but we also want to know where the minimum is, because this is where we have to swap the results. And Excel has a nice function for that called match, that's going to look for this value in this array. And then the result is 10, and that's correct because this is exactly where our minimum is. So what we want to do now, I will start slowly because probably you're not that familiar with Excel formulas, so I make a very simple formula where I'm just going to mark an X for the positions that we are going to swap. So if this guy is equal to the minimum, then this is a swap spot because that's the location of the minimum. So we can drag this formula this way, and then we have it everywhere. Oh, but we don't. We made a mistake. Does anyone who didn't watch the previous version of this talk know what I forgot here? Dollar, yeah, indeed. If we go to this guy where we would expect to have the cross, then we see that this green formula has been shifted this way, and that's not what we want, so we want to fix it with a dollar, and now we do get our X. And let's fix this row as well, because we're going to drag the whole thing down, so we don't need to make the same mistake again. We're just going to fix this with a dollar. Hoppa, there we go. We also need the other swap spot. So one of the swap spots is the minimum, but the other spot that we're going to swap is the first location. So we say the index of the swap is 1. And now we need the reverse operation of the match, which is called the index. It's a little bit confusing because in some programming language, index is the exact opposite. It's like match. But what this index function does is it gives us, in this array, this row and this column, the location. So there's only one row, so row 1, and then we want to have the position on the first column. So that gives us 13. So now we can fill in the second swap spot. The first swap spot is minimum, and the other swap spot is the location of the index. So if this guy is equal to the location of the index, then also a cross, because then we're also swapping. The only thing that's still missing now is this guy. So what happens in case we don't have to swap? That's super easy. If we're not swapping values, we can just pick the values from the previous line, because then nothing else happens to a row. So this is an easy part. Now we have the entire row. Everything stays the same, but here and there, we're going to have to do something. Let me add some conditional formatting. It's just easy. So if we're going to do a lot of calculations, it's easier if we make green and yellow where exactly we're swapping. Then we get a nice visualization like the tape we had in the Turing machine. Now we can fix our formula. So what happens here? It's actually pretty easy. If we're on the spot of the minimum, what we want then is the swap value. And if we're on the position of the swap value, then we want the minimum. So now we have our selection sort formula. We can take this, drag it down, and again, we made a mistake somewhere. Anyone spot the mistake? Yeah, the wrong minimum. We grab the same minimum all the time, and if we go there, you can see that it's always the minimum of this row, which is not what we want, because the first position is correct, so we need to shift it. And Excel's got you covered for that as well. We have an offset function that can move a reference through the spreadsheet. So you take this function and you move it. Well, initially we move it 0, and then we move it, so 1 minus 1. So initially we move it 0, then we move it 1, then we move it 2. So it goes this way, and then selection sort, and you see with the yellow boxes every time where it picks the value that it's going to sort. Super cool. But we want to go a bit further than that, because you're probably going to argue that this is not really a nice formula. You don't want to have indexes and matches and hard stuff. We want to have a nicer formula. So let's go deeper into the crazy stuff that Excel can do. Does anyone, I'm still excluding the people from last month, know what this syntax means? Anyone seen this before or used it before? You know, your next door neighbor probably does know this. No. I'll highlight it a little bit. Does this help? Maybe. This is a space in between, and it means the intersection of these two ranges. I don't know why they didn't just use an intersect function, but this is the way it is. If you add two, you get the result. We can use that because we can name this first line index, because that's what it is, the index of our number. And then we can change our formula a little bit from this into this. We can say we want to have the intersection of index and the column we are in now, and if that is equal to these, then the rest will happen. That makes it a little bit more readable. And this second part is, stay with me. This second part is optional, so I can drop this and then I will get the intersection of index and the column that I am in right now. So I can drop it, it means the exact same thing. If I repeat this trick and I pick the right names, and I mean this is what you have to do in another programming language as well, if I name these ranges, so I name this swap and index swap, then this turns into this. It's pretty cool, right? It reads like a novel. It's like, if the index is the index of the minimum, then swap, and if the index is the index of swap, then minimum. It looks like programming, don't you think? There's just one thing that is annoying, that E3. I want to have a good word, a good name there as well. I don't want it to look like cells and values. I want it to look like programming. But of course, I can use the same trick with an intersection because I'm intersecting with something else all the time. My previous row is dropping. So we need to go really deep into the cave of hidden Excel features to fix this, but we are going to get there. So what we need is a dynamic named range, a named range that can change, and this is possible. So probably you know this syntax. You've done this before, I guess, where you give a name to a specific cell. That's still pretty easy. But you can also give a name to something else. This doesn't have to be a cell. You can also say all you need is love, for instance, just a string. So you have a named range, still called a named range, but now it refers to a string instead of to a cell. And you can use that in the formula. So you can say all you need is love. Isn't that nice? Love is all you need. Super awesome. And there are other lyrics we can express as well with super cool named ranges in Excel. So there's another singer. Many singers have thought about what exactly is like the mathematical definition of love for some reason. So this guy, Paolo Nutini, says, however much I love you, you will love me more. Well, Excel can handle that, no worries. So we can define a name called myLove, which is a value. This is exactly like a string, but now we give a number. But we can do something crazier. We can say, okay, we have my love now. Your love is always more. So I can say your love is my love times some constant. So I refer to another named range in this named range. It works. So I can say your love is my love, and it just calculates. So we have a named range with a formula in it referring to another named range. Are we there yet? No. Bear with me. There's something else about love. Every day I love you more. So we need more and more craziness to express this with a named range. Because we sort of have a baseline now. We say day 1 our love is 15. And what we can do now is return the row of this number. So maybe you've done this before. If you have like the row of, let's say, B3, then the result is 3. But if you use this without arguments, you get the row you are currently in. And we can use that in the named range definition for love. Because what we can say now is yesterday's love is the address of the row above me and the column that I'm in right now. And now we sort of made a reference to the cell above us. Look at this. What we have here now, yesterday's love, is the cell right above me, C4. But now I have the location of the cell. That's not what we want. We want to have the value of a cell. So what Excel has for that is the indirect. And this is very much like the eval in JavaScript, where you put in a string and you get the result of the variable in that string. This is very similar. So you put in a string into the indirect, like B3, and what you get is the result, what is in B3. So this is equal to this, B3. It's just like a reference. So it just chops off the string, the quotes, and then evaluates it. So we can use that. We can put that around this, making the B4 that we had into a reference to the cell above us. So now we have this named range that's in here points to the value that is in the cell right above it. Wherever you will place it, it will always point above. And then the only thing we need to do is add the Van Buren factor for how much our love is increasing every day. And then we have a formula that in a named range that is dependent on the cell that you call it from. So every time you call it, it points above and it calculates the value that it is above it with a factor. We can use this. We can use this tricky technique to get rid of that filthy E3. It needs to go. So what we can do is, in a very, very similar fashion, make a reference to the row right above us. And this is where we're using the 3:3 syntax from all the way in the beginning of my talk. So we say, well, we want to have the previous row is a reference to the row above, colon the row above, the exact row above, and that turns this into this. Isn't that nice? It's really programming. If I'm in this position of the swap, I use the min, and if I'm in a position of the min, I use the swap, and otherwise I use the previous row. For comparison, selection sort in Python, But you think this is nicer, it's so much shorter, it's the same structure, but it's like one line instead of 10. Super cool. You cannot deny, I'm sure you cannot deny anymore now, that Excel is a program. Yeah, you need to do a little bit of work, but you also need to do a lot of work if you're programming JavaScript, and no one is complaining about that. Okay, people are complaining, but they're not calling it not programming, they're just complaining about a programming language. So, all the fun aside, I'm also like spending the last, I think, 5 minutes I have in this talk about like a pitch of my own research. So what I do at Delft University is, what we try to do is, if spreadsheets are code, then what does that tell us? It's not just for fun that we think, oh, like, we've proved that Excel is a programming language. Huh. No, if we know that spreadsheets are programming languages, we can use methods from software engineering to help people improve them. So this is my dissertation, and in my dissertation, I worked on code smells in spreadsheets. So who's familiar with the concept of code smells? Okay, a bunch of people. Code smells is the idea that certain pieces of code in your whole repository are smelly. For instance, a very long method. It's not necessarily said that a long method has an error in it, but you have this feeling that if you have a lot of long methods in your code base, maybe it might not be so well structured. So we've transformed those code smells into smells on spreadsheets. So if you have a long method, it's just as smelly as if you have a long formula. It's very similar structure and the same smells. So my answer was yes. We can transform methods from software engineering very well. We've done it with code smells to they actually help people understand what are the weak spots in their spreadsheets. So what we did then, after the code smells, is we built a refactoring tool, because if you say smells, then you say refactoring. If you have a smelly spreadsheet or if you have a smelly code base, then you want to do something about it. You don't just want to know, hey, this formula is very long. What you want to know is, now what? How do we improve the spreadsheet or the source, the code base? So we build a refactoring plugin for Excel. This is how it looks like. You can take a smelly formula. This is a smelly formula, for instance, because it's not very long, but it's not optimal, because you use a sum and a count here, where you could have also used the built-in average function, which is shorter and easier to read. So we spot that type of smells where people take more space than they need for the formula, and we tell people, hey, we can refactor this formula. We can apply the sum and count to average refactoring here, and that will turn this formula into this one. Get a preview, like if you use ReSharper, and this is a refactoring tool for Visual Studio, you also get a preview of how your code looks like, and if you like it, you can say, yeah, I want that, apply this refactoring for me, and you get a simpler version of your formula. And these transformations are entirely programmable in a little programming language that we made. So you can express your formulas. You see here, if I have the sum of a given range divided by the count of a given range, you can refactor that into the average of the same range. We haven't tested this language yet with spreadsheet professionals, but we think that the ones that can write VBA, that can write very complicated formulas, should also be able to express those refactorings in the language themselves. But we don't know. We yet have to test this language specifically with Excel user. And then, of course, if you say refactoring, then you also say, yeah, awesome. I don't have t-shirts, but if I had one, it would be for you, of course. If you say refactoring, you say testing. You don't want to go mess with your code without tests to make sure that everything before and after the refactoring is the same. Well, I would say you never want to be without tests, but especially if you're refactoring. And initially we thought, oh, this is going to be hard. It's already quite hard to convince professional developers that they have to test. How are we going to get spreadsheet developers that aren't even aware that they are developers? How are we going to get them to test? But this was typical ivory tower thinking about people instead of looking at what people actually do. Because when we started looking at spreadsheets that we got from companies we work with, we saw these type of things were pretty common. So what this says is, if the sum of these guys is not 100%, then output error. This is like a test or like an assertion. The user of this spreadsheet has written down in formula language this has to sum to 100, otherwise error. That's very much like a test. So we thought, instead of forcing people to test their spreadsheet, let's extract those existing tests from the spreadsheet and present those to the users to have like a baseline of the test in the spreadsheet. So what we do now is we made a tool, Expector, also an Excel plugin, that can detect this type of tests. And the user gets a pop-up like this. We say, hey, in D11, we have found something that looks like a test. And even by using a heuristic on words like okay and good and bad, we can detect what part of the passing and what part is failing. And if the user saves that information, we secretly make a test suite without telling him, and then the user can run the test. So we can say, hey, find me everything that's tested. So we say this is a test, and it passes. We know that because we know if it's not 100, it's an error. So we're assuming that 100 is not an error. Some coverage analysis with that, because if you look at this cell, it refers to these cells. It uses those cells. So you could say we consider those cells tested as well, because in the end, it all comes together in that test, so they are at least covered in the flow that ends in a test. And in a similar fashion, we can say these cells aren't tested yet, because they depend on this guy, and there is no test formula in this formula. So in this way, we try to convey sort of the testedness, the robustness of the spreadsheet to the user by showing these parts are tested and these parts are still untested. We don't know if they're okay or not. So that's everything I wanted to share with you. I'm going to wrap up now. Summarize my entire talk in like 1 minute. So in case you came in late or you were still processing your coffee, maybe this is your second chance to get the entire talk, and otherwise it's good preparation for question asking. Spreadsheets are code. Main message, super important, like tell all your friends, spreadsheets are code. They're not like someone's hobby. They are a programming language. Because they are used for the same problems. They are mathematically, provably, just as complex as any other programming language. And they suffer from typical programming languages problems. Not only are they a programming language, they are a super cool, hip programming language because it's live programming. It's purely functional programming that everyone can do. Like no language in the world has that character. To prove it to you even more, I've implemented sort in a cool way that's very readable and very comparable to how you would do it in other programming languages. If spreadsheets are code, you should be able to use software engineering methods on them to improve them. And this is exactly what my line of research at the University of Delft is about. We have applied methods from software engineering, like refactoring and testing, to end users with quite some success. If you think, hey, that's very cool, you can download both the Excel plugins from my website, or you can have a look at the website of my research lab where I to also really like this stuff, or you can send me an email or a tweet.
I still think it's amazing.
Thank you.
But who did not know what selection sort was? She didn't ask for the time complexity of it, she just asked what it was. But, well, maybe we should add that to the interview question. But, any question? Oh, before Martijn, yeah, could you start setting up? Because you're next. Any questions about Excel? Yes. Please repeat the question for our Finnish viewers.
I will do.
Testing is covered now, it seems. Is there also a way to, like version your Excel files, see differences, that kind of stuff developers like?
Yeah, there's actually a UK-based startup that's called SpreadGit. And it's exactly what you think it is. It's like GitHub for spreadsheets. Okay, they're still pretty bad at it, just started, but check it out. It's super cool stuff. Yeah.
What is the future of Excel in big data?
That's a very good question. So what is the future of big data, of Excel in big data?
Or the other way around.
Or the other way around. Yeah, I know. Who are you asking? I think Microsoft is trying to keep people in Excel. So if in the newer versions of Excel, they've added more powerful analysis tools like Power Pivot and Power Query that enable the analysis of millions of lines of data. So I think they want to try to use it at least as an interface. I think that's a wise decision. Many big data systems or data analysis tools use Excel as a front end, or at least as a tool where people can import and export their data to. Something like a spreadsheet, doesn't have to be Excel, but a spreadsheet-like interface where people can play around with their data in an easy fashion, I think that will remain forever, even if it's not Excel.
You can already run Power Pivot against our cluster.
Huh, I didn't know that.
You need the JDBC driver and Windows, but for Power Pivot.
Obviously.
But then you can do it. Final the data scientists are all of a sudden asking questions. The Excel is more hipper than R, because R is like flaky functional.
Side effects. Oh.
Serious question, like open source and LibreOffice and OpenOffice, will all these tools work for that as well, or is it purely copying Microsoft?
Yeah, so the ideas, of course, are easily transferable. The ideas aren't tied to Excel, but we like to do experiments with especially in big companies, because that's where big risky spreadsheets are. And unfortunately, or fortunately, it depends on your standing, those type of companies use Microsoft. So that's why for us as researchers, it makes most sense to develop those tools for a platform where we are going to find industrial users for. But yeah, feel free to re-implement. It's all published, so it should be very easy to do it for another spreadsheet platform.
Final question.
Which part of Excel? There are some choices. For instance, the space I showed, 2 ranges with the space in between. I'm not sure it has very like heavy semantics. It means a lot, but you hardly see it. And the same goes for array formulas that are super powerful, but the syntax is quite like concealing. It's hard to see what's going on. I think Microsoft made the trade-off between ease of use and the use of complex structures, always towards ease of use, which is probably a good choice. But if you want to do very deep, heavy stuff, like the ones I showed you, it can get nasty quickly without like testing tools.
Okay, thank you very much. Give a round of applause for Feline. And also, please give your microphone to Martijn. One talk before a short break.